Okay, so to continue, so let us now discuss about stars. So since the beginning of time, 'di ba? So lahat naman during those times nung wala pang technology, wala pang everything, okay. Kumbaga, hello pa yung civilizations. So our ancestors are always staring at the night sky, you know. So they have been fascinated. Then uh they might be the ano no, the source of everything, of the stories behind the stars. So during that time, so they saw thousands of bright glittering points of light in the sky, you know. So it must have been very breathtaking view for them, since that there is no other forms of entertainment during those times, no? Especially walang light pollution, no? So they didn't know what those things were up there, but it didn't stop them from making up stories about them, transmitting those tales to their generations through generations, which later on developed as their form of culture, as form of their practices and traditions dun sa kanila. So today, no, so yung time natin, so stargazers have the same reactions to our ancestors, no, with the starry, with our starry night. So with amazements and wonders, diba? So now when we look at the night sky, we know that we are seeing stars of all ages, no, and stages of evolution, stages of morphology. So meron tayong na mga nakitang mga young stars, meron tayong nakitang mga old stars, okay? Also, these stars have the fingerprints of amounts of knowledge that we can extract from the stars, especially when we discuss about evolution and morphology of our galaxies and of our universe, especially for those under the stellar science. So we will not discuss more or in details about the sun, no, because this should have been discussed to you during the space science subject. Okay, so we will discuss ano, uh, more about stars outside the solar system. So you would notice, no, saan kaya nanggaling yung mga pangalan ng mga stars. So basically, what it has been thought that most of the stars ay nakapangalan sa Arab, okay? Sa mga named by Arab countries, especially those stars na nagsisimula sa Al, okay? AL, okay? Parang Al-Bali, yan, Aldebaran, Alderamin, Alfrik, Algedi, Algenim, Algol, 'di ba? Alayot, Al-Qaid, Al-Kes, Al-Maq, Al-Nair, Al-Nilam, Al-Nitak. So 'yun. So 'di ba parang ano siya, common sa Al Jazeera, yung mga ganun, no? So yung mga siya, Muslim in origin. Okay. But syempre there are also stars, no? Mm, yung mga stars natin, for example, Arcturus and Betelgeuse are from Greek and Arabic words. Yung bright stars na Sirius, okay, which is also a Greek name, is also known as Alpha Canis Majoris, or Latin for big dog. And this is because, no, yung brightest stars in the constellation of Canis Major. So the alpha, so later on you will notice, no, yung mga alpha sila, alpha, beta, gamma. So the alpha indicates the brightest stars among them. Okay, yung beta is the second brightest among them, so on and so forth. Okay. So, yung mga stars natin, so meron silang tinatawag na luminosity. So, yung luminosity is the total amount of power, while apparent brightness is the amount of starlight reaching the Earth. So, basically, these stars are the initial stage of understanding astronomy throughout the years, no? Throughout our evolutions. So, yung distance natin between them, just like no, it could also be AU, or it could be light years to light years, in between light years, no? So the distance is the most important and the most difficult measurement. The distance can be determined using simple trigonometry and a common optical effect, but you could also use your fingers. Siguro naman naturo naman sa inyo yan sa observation, no? Yung about degrees just using the fingers. So when we talk about brightness ng mga stars, no? So when we say apparent brightness, so more specifically, we define this brightness as amount of power. Diba? While when talk about luminosity, so it is the absolute sense of talking about the brightness. So yung apparent magnitude, o yung iba you would notice it's ano no, it's either a magnitude, no, yung iba ang term nila ay magnitude. So when we say magnitude, so apparent magnitude, it is how bright a star appears in the night sky. While for absolute magnitude, so that's the luminosity of the star in the same distance, no? So in absolute magnitude, so it indicates how bright objects would appear if they were located or putting all stars at standard distance compared to others. Kumbaga kung papipilahin mo sila lahat, no, para malaman natin yung ano nila, yung kanilang absolute magnitude. Okay. Okay, so again, so this is the ano no, this is the HR diagram or the uh, uh Hazard-Hertzsprung diagram. So this diagram shows the plots, okay, plots of the different stars, no. So it could quickly become one of the most important tools in astronomical research as nakalatag lang lahat ng mga ano ng mga stars. Okay, so again yung Hertzsprung-Russell diagram o HR diagram. Okay, so yung ating horizontal axis, okay, represents stellar surface temperature. Okay, yung OB, a fine girl is me, di ba? So, as we've discussed, so that corresponds to the spectral type. So the temperature decreases from left to right because the HR diagram are based on the diagram sequence, yun nga yung OBAFGKM. Okay? Then the vertical axis represents stellar luminosity. Okay? In units of the sun's luminosity, or tinatawag nating L, okay? So stellar luminosities span a wide range. So we keep the graph compact by making each mark represents luminosity 10 times as large as that of the prior mark. Okay, so ito po mapapansin nyo, 10, 10 to 10, 3, 10 to the 4, 10 to the 5, 10 to the 6. Okay, so yung main sequences, okay, mapapansin nyo yung main sequence na sa gitna. So main sequence, so our sun falls along the main sequence, so a line of stars extending from the upper left of the diagram to the lower right. So most stars are main sequence stars, so which shine by fusing hydrogen into helium cores. Next is the gas giants, or the gas and giants and the supergiants. So stars in the upper right of the HR diagram are more luminous than main sequence stars of the same surface temperature. So they must therefore be very large in radius, which is why they are known as giants and supergiants. So sila yung mga malalaking stars. Then next is yung mga white dwarfs. So white dwarfs are stars in the lower left. So they have high surface temperatures, but they have dim luminosities and small radii. So these stars are known as white dwarfs. Okay, so mga maliliit sila. Next is yung mga about masses of the main sequence. So yung stellar masses, yung mga naka-purple labels. Okay, napapansin yung purple labels, yung 0.01 m, 0.3 m, then 1 m, 1.5 m, so on and so forth. Yung mga purple. Excuse me. So it shows a decrease from upper left to the lower right on the main sequence. So yung mass ng stars tulad nito, 60 m, ibig sabihin 60 times the mass of sun. Then 30 m means 30 times the mass of sun, so on and so forth. Okay. Excuse. So dito as compared, no, yung Betelgeuse is a supergiant star. Okay, as compared to Aldebaran as a giant star, and as compared to our sun as a main sequence star. Okay, and that here, what is being shown is the class and its corresponding description. So if a star has is considered as under class 1, so it is a supergiant star. If it is a class 2, it is a bright giant star. If it's a class 3, it is a giant star. If it's a class 4, it is a subgiant star. And if it is a class 5, so that is a main sequence star. So for example, then you need to see the graph no dun sa O, B, A, F, G, K, M stars. Okay? So with that, um, you would also notice that, for example, si ating sun, okay, si sun ay is a type of main sequence star G25, okay? So G25, so sabihin 5, so it is a main sequence star. Okay. Next is the lifetime. Okay, star's lifetime. So for example, no, so this is stellar lifetimes, yung mga naka-green label, mga naka-green label na stars, green label dun sa diagram. So it shows the increase from the upper left to the lower right of the main sequence. So high mass stars live shorter lives because their high luminosities mean they consume their nuclear fuel more quickly. Okay? So mas mabilis silang nagko-consume kaya mas less ang kanilang, kumbaga unti-unti, no? Mas nagiging less na ang kanilang lifetime. Okay, so the most important patterns here for the HR diagram is that the HR diagram provides information about stellar radii, kaya yung kanilang radius, kung gaano sila kalaki. Because the stars, take note take note of this, because the star's luminosity depends on both of its surface temperature and its surface area o yung radius ng star. So if two stars have the same surface temperature, one can be more luminous than the other if it is larger in size. So stellar radii therefore must increase as we go from the high temperature, low luminosity corner on the lower left of the HR diagram to low temperature, high luminosity corner on the upper right. So most of the stars fall somewhere along the main sequence, no? The prominent streak running from the upper left to the lower right on the HR diagram. Saan na ba yun? Ito, no? So papansin nyo, andyan dyan ng most stars. Then notice that our sun is on this main sequence. Okay, the stars in the upper right are called the supergiants. Okay, they are very large, okay, and very bright. Below the supergiants are the giants, or the giant stars, which are somewhat smaller in radius and lower in luminosity, but still much larger and brighter kaysa dun sa mga main sequence. Okay, stars near the lower left are small in radius and appear white in color because of their high temperatures. Okay, ang tawag sa kanila ay white dwarfs. Okay, so dito, what is being shown sa ating diagram, ang white dwarf natin na nandiyan dyan ay si Sirius B at si Procyon B. Okay. So, yung ating stellar classification, so meron tayong spectral type. Okay, spectral type. So yung spectral type natin, yun nga, designated by OBFGKM. Okay, so yung OBFGKM o yung spectral type tells us about the surface temperature and the color. Okay, so kung halimbawa meron tayong O stars, so O stars are the hottest, okay, and the bluest, while the M stars are the coolest and the reddest, okay, or mas red. Okay, then yung y-axis natin, that is the luminosity class or designated by a Roman numeral, yun nga, yung 1, 2, 3, 4, 5. Okay, so it's based on its luminosity, but also tells us about the star's radius. Okay, so luminosity class 1 stars have largest radii, while radii decreasing to luminosity 2 class 5. Okay. Then, for full classification, so we both use spectral type and luminosity class para ma-classify yung star. Okay, so for example, like to complete the classification yung sun, 'di ba? Kung mapapansin niyo kanina si sun nakalagay doon G25, 'di ba? G25. So to complete this classification, so yung sun natin is G25, okay? G2 means the spectral type is yellow-white in color. Okay? G2 ibig sabihin yellow-white in color. And the luminosity class 5 means it is a hydrogen fusing main sequence star. Okay? So, another is yung Betelgeuse, diba? So, Betelgeuse is M21, okay? M21. So, ibig sabihin, uh, it is a red supergiant, okay? Then Proxima Centauri is M55. Okay, M55. So M55 is similar in color and surface temperature to Betelgeuse, but far dimmer because it is smaller in size. Okay. So when it comes to evolution of stars, so yung HR diagram also shows um, the evolution of stars or possible evolution of stars, especially if they are white or if they are more massive than the others. Like, ano pa ba? So, yung mga white dwarfs naman, no, dito, yung mga white dwarfs. So, um, white dwarfs are hot, okay? Basically, they're hot because of these remaining embers of former giants. So, white dwarfs are hot because they are essentially exposed to stellar cores. So, malit lang sila, so malapit sila to sa kanilang cores. But they are dim because they lack energy source and radiate only their leftover heat into space. So, a typical white dwarf is no larger size than Earth, okay? But has mass similar to that of our sun. So white dwarfs must be made of matter compressed to an extremely high density. So unlike anything found on Earth, no? So ganun sila. Next is stellar temperature. So when it comes to stellar temperature, so tulad ng na-discuss natin kanina, no? Doon sa along x-axis ng HR diagram, pati doon sa classification natin doon sa ano sa mga stars. So with that, so these are some examples, no, when it comes to temperature. So yung spectral type O, so example niya is yung mga nasa Orion's belt. So that's about approximately more than 33,000 Kelvin. Okay. So yung mga ano niya, wavelength lies less than 89 nanometers or that's about approximately ultraviolet. Yung spectral type B, so example is si Rigel. Okay, so ang temperature niya ranges from 33,000 to 10,000 Kelvin. Yung spectral lines niya ay neutral helium but has moderate hydrogen lines. Yung spectral type A, o yung example natin is Sirius, yung kanina, is about having 10,000 Kelvin to 7,500 Kelvin. Okay, it has very strong hydrogen lines. Then yun, sa spectral type G, 'di ba si G si Sun and Alpha Centauri A. So ang temperature ng Sun natin it ranges from 6,000 Kelvin, 5,200 Kelvin to 6,000 Kelvin. So it has weak hydrogen lines but has strong lines of ionized calcium kaya siya nagmumukhang color yellow, 'di ba? Then yung Betelgeuse and Proxima Centauri is about less than 3,700 Kelvin. Okay, it has several strong molecular lines. Kaya ganun yung kanyang kanyang structure.